Lesson 7.7, reciprocal trig identities. So reciprocal just means flipping something. So all of these we should already know. Sine of x really doesn't have any kind of reciprocal other than if it was 1 over cosecant, it would reciprocate, but you're not going to see that on this. Cosine, same thing. It would be the same as 1 over secant. You don't really see that, but we know tangent is sine over cosine. So if you see this fraction, you can replace it with tangent. If you see cosecant, you know that that's the reciprocal of sine, so we would say it's 1 over sine. Same thing for secant. If you see it, then you can replace it with 1 over cosine. And then cotangent has two identities you might need to use. You could make it tangent by putting it 1 over tangent, or you can make it the reciprocal of what tangent's fraction was and flip this so that it's cosine over sine. Okay, so we're trying to simplify to one single trig function with no denominator. That's our goal. And so I always try to make everything be like sines and cosines. So cosecant is really the same thing as 1 over sine. And I'll just use whatever they have here. They have theta. Times tangent, I'm also going to turn into terms of sine and cosine, which is right here. That would be sine of my angle over cosine of my angle. And then I simplify. So these would cross cancel, just like multiplying any kind of numbers. I hit 1 over cosine, but they don't want us to leave a denominator or a fraction. And so what is 1 over cosine? That is really secant. And so I would put that this really equals secant of theta. And there's not always going to be just one way to get to that point. Okay, number 2. Tangent times cotangent squared. So let's just see what would happen. So this, let's keep it tangent. I know cotangent is really 1 over tangent, and it's squared. So that would be 1 over. Tangent must also be squared because cotangent was squared. So these would be reciprocals of each other. And so then I can cancel out a tangent here and one of them here, right? It's kind of like having this. I can take one out of here and then take one out of here. So now I have 1 over tangent. And that is something. 1 over tangent is really equal to cotangent. Oh, not cosine, cotangent. Okay, again, not the only way to get there. You could have used all sines and cosines and arrived at the same thing. Tangent could have been written as sine over cosine. Cotangent could be this, but you're going to have to square both of them. So that would be cosine squared over sine squared. 1 would cancel here and here. Cosine would cancel here and here. So you end up with cosine, sorry, it's supposed to be theta over sine of theta. Cosine over sine is cotangent. So either way, same answer. Number 3, we have secant squared times cosine squared. I don't know why that 2 is up there like that. Secant is 1 over cosine squared. And then I'm going to keep this cosine squared. And so what happens here is this completely cancels out and just becomes a 1, and 1 times 1 is 1. So when you take something times its reciprocal, it cancels each other out. Just like if I had 2/3 times its reciprocal of 3/2, everything cancels and it becomes 1. And then number 4, we have division. Cotangent, I'm going to change into, not 1 over tan because I'm not going to have a tangent here. Let's do cosine over sine. And then cosecant, let's change into 1 over sine. We've got a complex fraction. We'll multiply by the reciprocal. And then the sines would cancel out, so I get cosine of theta over 1, or cosine of theta. Number 5, I've got division. Things are getting squared. Cotangent squared, I'm going to change into cosine squared over sine squared over cosine squared, which is really over 1. I'm going to multiply by the reciprocal. cancels. These cancel out, become 1. So I get 1 over sine squared. 1 over sine would be cosecant, but since it's 1 over sine squared, it's going to be cosecant squared of theta. And then number 6, tangent squared would be sine squared over cosine squared. Secant squared is 1 over cosine squared. Something else you can do instead of multiplying with the reciprocal, if this is a denominator and this is a denominator, they're going to cancel out. Because you can see it if you flip. See how they become diagonal, so denominators cancel, numerators cancel. So I end up getting sine squared of theta over 1, which is just simply sine squared. And that's it.